Hello everyone, we are going to look at this FRQ that is calculator friendly and go through and try to see how to do it. So read through the directions at the beginning, get familiar with those. The problem really starts right here. Let f be a twice differentiable function. They give you the y-intercept of the original function. We'll need this later. The derivative of the function, that's what we are given. This is the derivative. Notice that the domain is -2 to +2. Find all values in that domain where there are critical points. Classify each as a max, a min, or neither, and justify your answers. So if we go to the graph, hopefully you can see it here. It is a sine function where the input then is a quadratic. So a sine function is never going to go above 1 or below -1. And we are going to then try to find where the zeros of this are, because those zeros will represent the critical points. Now I found one here by going to second trace. When you get that calculate menu, I selected 0 and then I bracketed it on the left and the right, and up this came. This is a good example of round off error. That 0.999 means really that's at x equals 1. You should have the street smarts to know that. I'm going to find this and that as the other two zeros, and I'm going to do it by quickly going to intersect. That's option number 5. As long as you've typed in a line there at y equals 0, you should see that. Now, annoyingly, I'm going to go to the window first actually and see more in the -y. It's incorrectly here at a minimum of -1.5, and it should be a maximum of about 2, let's say. That'll probably show up better. There we go, that's more clear. And if I do then second trace and then do intersect for 5, I'm going to go over here. I'm going to get in the region. I have an equation that's in there that's y2, I think it is. And if I choose this as my first curve, and then you can see y2 equals 0, that's my second curve. I hit enter, and I hit enter again, and then I'm going to get -0.773. That's my other one. Write that down. And then my last one will be over here, so I'm going to get it over there. And I'm going to do the same thing. Second trace, intersect is option 5. Whoops, now I need to move it over. I shouldn't have moved it that time. And there's, I'm in the ballpark. I hit enter. I hit enter again. I hit enter a third time, and there it is, -1.507. I would write that, 507. Okay, so I'm going to write those down. If there were intervals of increasing and decreasing, I could use those to help me with that. But if I go back to the actual question, justify each, that's a good point. Go back and say, I know that this point is an area where the slope has been increasing and then goes to 0 and then is decreasing. There's a sign change there from positive to negative slope. So it's going up and then it turns and goes down. That's a local max. This one, for the same reason, but conversely, is a local minimum because it's decreasing. It's a negative, and then it changes to positive. Here, it's increasing, and then it stalls out, and it momentarily is level at that 0, and then it's increasing again. So that is neither a local max nor a local min, and the reason is that there's no sign change. All right, so then on we go to the next bit. Use the line tangent to the graph at x equals 0 to approximate. Okay, so this is a linearization here. We know that when x is 0, the function is at 4. So we're dealing with the point 0, 4. We can put that into point slope form. We just need to know the slope here. I'm going to use my derivative at 0 to predict this point here. So if I go back to my graph, I just need to hit the trace button, and then I type in 0, and it appears there. When I hit enter, that's the actual value. That is my slope of that line, 0.841. So if I type that into an equation, then I will get, in point slope form, y minus 4 equals 0.841 times x minus 0. That's just 0.841x. So if I go and do second, quit, and then clear, I know that my y value is going to be equal to, when I move the 4 over, it's going to be 4 plus then my point, gosh, I have to go 8, 4, gosh, was it 1, I think? And then times my value I'm trying to approximate times 0.25. And I would hit enter, and there I would have my approximate value at 0.25 based on my linearization there, assuming it was 0.841. Let's just check quickly. And 0.841 it was. Good. Okay, on to the next one. Then it says on the interval from 0 to 0.25, f prime of x is greater than 0. It's increasing, and f double prime of x is less than 0. That means it's concave down. Things that are concave down are curved like this, so my linear approximation is going to be an underestimate, because things that are concave down with tangent lines fall below the tangent line. So that would be your justification. Then using the mean value theorem, explain why the average rate of change of f over that interval cannot be 1.25. And that's because if you go back to the graph and look, it's a sine function, and sine functions here can never be more than 1. So it could never be 1.25. And that has to do with the range of the sine function. Okay, that's a good start. That FRQ is pretty good. There's another one very, very similar to it, I think number 13 in the quiz that I assigned. You can find others on the College Board. Good luck, everybody.